All right, we're going to pull back the curtain on something wild today. A piece of tech that's been hiding in plain sight for, get this, over 50 years. And it's not just some relic, it's powering some of the most critical systems in our world. It's a crazy story of ingenuity, some really weird-looking code, and a design so ahead of its time, it's still kicking.
So let me just start with a question for you. What if I told you that your most sensitive data, I'm talking about your medical records, your lab results, maybe even your bank transactions, what if all of that was running on technology from the 1960s? You know, back when the Beatles were still putting out new albums.
Well, the wild thing is, it probably does. Seriously. This isn't some what-if scenario. It's the hidden reality of our digital world. And the tech behind it all has let's just say, a very unusual name.
So what are we talking about? It's called MUMPS. Yeah, MUMPS. And despite its age, it is an absolute giant. It's this invisible language that has just quietly become essential to, well, pretty much everything.
Just how essential are we talking? Well, take a look at this. MUMPS-based systems are the backbone for the electronic health records of over 78% of patients in the United States. I mean, just let that sink in. That is a staggering footprint for a technology most people have never, ever heard of. And we're not talking about small companies here. These are massive, modern organizations. The U.S. Department of Veterans Affairs, their entire medical records system runs on it. Epic, one of the biggest names in healthcare software, built on it. Quest Diagnostics, the Bank of England, Barclays Bank. The list just goes on and on. These are mission-critical systems.
So you got to be asking why. How is this 1960s tech still so dominant? To figure that out, we have to go back, way back. Back to where it all began. A hospital in Boston that had a very specific and a very, very difficult problem to solve.
This timeline really puts it all into perspective. MUMPS was born in 1966 at Mass General Hospital. Now think about that. This was before IBM's famous IMS database, the one they used for the Apollo program. And it was years before the relational model, you know, the foundation for pretty much all modern databases, was even a thing. MUMPS was a true pioneer, out there on the frontier.
The team at MGH was facing like a perfect storm of challenges. The computers they had were incredibly primitive. Memory was so scarce you could measure it in just a few thousand characters. And the worst part? Medical data was, and honestly still is, super complex and messy. It just doesn't fit into neat little rows and columns like a spreadsheet.
And this diagram just illustrates the problem perfectly. A patient record isn't some flat file. It's a hierarchy, right? It's like a tree. A patient has admission records, and those have lab results, and those have individual tests and dates and values. The early databases just weren't built to handle this kind of nested, unpredictable information.
So faced with all these constraints and a total lack of tools they could just buy off the shelf, the MGH team did something totally radical. They didn't just build a database. No, they built everything.
They created this complete, self-contained ecosystem. It was a multi-user operating system, a programming language, and a database all rolled into one super efficient package. They basically had to, because nothing else existed that could do the job.
The absolute genius at the heart of MUMPS is this concept called global arrays. Now, forget everything you know about tables and schemas. A global array is a persistent, disk-based data structure that works just like a tree. It's multidimensional and it's sparse, which is a fancy way of saying you only store the data you actually have. No wasted space. And this is how that idea actually works. The data is organized in a way that just makes sense. You start at a root and you branch out. Each little index in the array is just another step down a path in the tree. It's an incredibly intuitive way to model that messy, hierarchical data we were talking about. And here's what it looks like in practice. This single line of code stores a patient's blood pressure. See that little caret symbol at the beginning? That means it's a global. It's being saved right to the disk. And we're just navigating the tree, patient number 123, down to vitals, then over to BP. There's no need to define a table or pre-allocate space. You just set it. For the time, this was absolutely revolutionary.
Okay, I know what you're probably thinking. That code looks a little weird, a little strange, and you're not wrong. MUMPS is famous, or maybe infamous, for its super terse syntax. But like everything else about it, this was a design choice born from some really harsh necessity.
Just look at this comparison. Modern code is all about being verbose and readable. MUMPS code is the complete opposite. Commands are abbreviated to a single letter, S for set. Variable names are kept as short as possible. But why? Well, because in their world, every single character mattered.
And here it is, the aha moment. Memory was so ridiculously tight that they couldn't even afford to compile the code into larger binary files. They ran the source code directly from an interpreter. So shorter code literally meant you could fit more programs into that tiny bit of memory at once. It was a hack that allowed for multitasking on hardware that was never, ever designed for it.
This is what it looked like in its natural habitat. It's a direct, no-frills interface that really reflects its origins. It was built for pure efficiency and speed, above everything else. Every single design choice was a response to the severe limitations of the time.
So why are we still talking about this today? Because those very limitations, the things that made it so weird, forced a design that almost by accident was perfectly suited for the future of computing. Let's unpack its incredible legacy.
Okay, so check this out. MUMPS was basically NoSQL decades before anyone even came up with the term. Its flexible schemaless design is perfect for messy real-world data. It's incredibly fast, it can handle enormous data sets, and it ensures data integrity with something called ACID compliance, which is super important. It was built to be lean, and that leanness translates to raw performance, even today.
And that performance and flexibility, that's exactly why its dominance in healthcare continues to this day. We're talking about many of the largest and most well-known hospitals in the world. Their electronic record systems? Dig deep enough, and you can often trace the underlying technology right back to that 1966 project at Mass General. And probably its most significant implementation is a system called Vista. This is the secret engine behind the medical record system for over 8 million veterans in the United States. It's a massive, life-saving piece of infrastructure, and guess what? It's powered by MUMPS.
So here's the crucial point, the main takeaway. MUMPS is this powerful lesson in engineering, a system that was brutally optimized for the constraints of the 1960s, scarce memory, slow disks, messy data. It ended up having the exact features we're all chasing today: flexibility, scalability, and speed.
Which really leaves us with a final thought to chew on. In an age where we have seemingly endless computing resources, what can this so-called dinosaur of a language teach us about building robust, flexible, and truly efficient software for the future? It seems the past might have a lot more answers about the future than we think.